Last stage we read the spec sheet of every modern model, RMS norm, rope, GQA, mixture of experts, but a spec sheet describes a finished model. Where does a model actually come from? It comes from three verbs: pre-train, continue pre-train, fine-tune. They sound the same. They are not, and the difference is exactly one thing: which tokens get a gradient. Pre-training is cool. You take trillions of tokens of raw text, the web code, books, and you play one game, predict the next token. Every single token in the stream gets graded. No human labels, just the text shifted by one. That is why it scales to trillions of tokens, and that is why it costs millions of dollars. Continued pre-training is a residency. Same game, every token still graded, but now the diet is skewed toward your domain. Say medical text or your company's code. The danger is catastrophic forgetting. Lean too hard on the new domain, and the model forgets how to format an answer or follow an instruction. The fix is replay. Mix the old general data back in, roughly 50-50, with a smaller learning rate. Supervised fine-tuning is shadowing an expert. Now the data is pairs, a prompt and the ideal answer. And here is the twist. You do not grade the prompt. You mask it. The model only gets a gradient on the answer tokens. You are not teaching it to predict the user's question. You are teaching it to produce a good reply. Three verbs then. Same loss function, three different jobs. The cost is the gradient mask. Every token, answer only. And on the NVIDIA stack, each verb has a home. NeMo Curator builds the data. NeMo Framework on Megatron Core runs the pre-train and the SFT. And a single distributed checkpoint carries the model from one stage to the next. One caveat before we draw the pipeline. Everything so far is the decoder objective. Predict the next token, left to right. Encoder style models like BERT play a different game. Masked language modeling. Blank out about 15% of the tokens and predict the missing ones using context from both sides at once. The original BERT bolted on a second task too. Next sentence prediction. Does sentence B actually follow sentence A? Same cross entropy, but the mask is over hidden tokens, not future ones. That is why encoders are built for understanding text and decoders for generating it. Let me draw the whole pipeline once, because every episode in this stage lives somewhere on it. Raw corpus on the left, your fine-tuned model on the right. Raw corpus goes into curate, clean, dedup, filter, then gets tokenized into a binary corpus, NeMo's .bin and .edx files. That feeds pre-train, which produces the base model. Loss on all tokens, I will glow that box green. The base checkpoint flows into continued pre-train. Still loss on all tokens, but with a replay inset, 50 general, 50 domain. Out comes a domain shifted base. That checkpoint flows into SFT. Watch the loss mask change. The prompt tokens go gray. Only the answer tokens glow gold. Answer only loss equals true. Outcomes an instruction following model. One pipeline, three loss masks. But notice the very first box and a curate. Everything downstream is only as good as what goes in. Next, garbage in, garbage out at trillion token scale. And the NVIDIA tool that cleans it, NeMo Curator. Thanks for watching. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.